NEC 250.142b addresses the use of a grounded circuit conductor for grounding equipment on the load side of the service disconnect. Exception number 2 to this rule outlines specific conditions under which grounding meter enclosures to the grounded circuit conductor is permissible. These conditions are firstly, that no service ground fault protection is installed, and secondly, that all meter enclosures are located near the service disconnecting means. The reasoning behind these conditions is rooted in electrical safety and the minimization of potential hazards. Without service ground fault protection, fault currents could flow through the grounded circuit conductor if it is used for grounding the meter enclosures. To understand this, it's important to understand how ground fault protection works. Ground fault protection is designed to detect and interrupt ground faults, which are unintentional electrical connections between a live conductor and ground. These faults can occur due to installation failure, accidental contact, or other reasons. When a ground fault occurs, a ground fault protection system detects the imbalance in current between the supply conductors and the neutral conductor. If the imbalance exceeds a predetermined threshold, the ground fault protection system trips a circuit breaker or other disconnecting device, interrupting the flow of electricity and preventing potential hazards such as electric shock or fire. Now consider a scenario where service ground fault protection is not installed. In this case, if a ground fault occurs within the meter enclosure or connected equipment, there is no mechanism to quickly detect and interrupt the fault current. Instead, the fault current would flow through the grounded circuit conductor, which is also being used to ground the meter enclosures. This situation can create a safety hazard because the fault current could energize the exposed metal parts of the meter enclosures. Anyone coming into contact with these energized parts could be exposed to electric shock. To prevent this hazard, exception number 2 of NEC 250.142b specifies that the use of the grounded circuit conductor for grounding meter enclosures is only permissible if no service ground fault protection is installed. This ensures that in the event of a ground fault, the fault current will not flow through the grounded circuit conductor and energize the meter enclosures. The second condition of exception number 2 is that all meter enclosures must be located near the service disconnecting means. The purpose of this condition is to minimize the impedance of the grounded circuit conductor used for grounding. Impedance is the total opposition to the flow of alternating current in a circuit. It includes both resistance and reactance. Resistance is the opposition to current flow due to the material of the conductor, while reactance is the opposition to current flow due to the inductance and capacitance of the circuit. The impedance of a conductor is directly proportional to its length. The longer the conductor, the higher the impedance. When the meter enclosures are located near the service disconnecting means, the length of the grounded circuit conductor used for grounding is minimized. This reduces the impedance of the conductor, which helps to ensure reliable grounding. A low-impedance grounding path is essential for several reasons. Firstly, it helps to minimize the voltage drop along the conductor. When fault current flows through a conductor, it causes a voltage drop. The magnitude of the voltage drop is proportional to the current and the impedance of the conductor. If the impedance of the grounded circuit conductor is high, the voltage drop can be significant. This can result in overvoltages in the meter enclosures, which can create a safety hazard. Secondly, a low-impedance grounding path helps to ensure that fault currents are quickly and effectively conducted back to the source. This allows protective devices, such as circuit breakers and fuses, to operate quickly and clear the fault. If the impedance of the grounding path is high, the fault current may be limited, which can delay the operation of protective devices. This can increase the duration of the fault and the potential for damage. In summary, the two conditions of exception number 2 of NEC 250.142b are designed to ensure electrical safety and reliable grounding. The absence of service ground fault protection prevents fault currents from energizing meter enclosures, while the proximity of meter enclosures to the service disconnecting means minimizes impedance and ensures effective grounding. Consider a practical example to illustrate these concepts. Imagine a residential service where the meter enclosure is located on the outside of the house, near the service entrance. The service disconnecting means is located inside the house, in the main electrical panel. In this scenario, it would be permissible to ground the meter enclosure to the grounded circuit conductor if no service ground fault protection is installed. This is because the meter enclosure is located near the service disconnecting means, which minimizes the length and impedance of the grounding conductor. However, if the meter enclosure were located far away from the service disconnecting means, such as in a detached garage, it would not be permissible to ground it to the grounded circuit conductor. This is because the increased length of the grounding conductor would result in higher impedance and a greater risk of voltage drop and unreliable grounding. It's important to note that NEC 250.142b and its exceptions are complex and should be interpreted and applied by qualified electrical professionals. The specific requirements and limitations of the code must be carefully considered in each installation to ensure compliance and safety. It is also important to note that even when the conditions of exception number 2 are met, it may still be preferable to use a separate equipment grounding conductor to ground the meter enclosures. A separate equipment grounding conductor provides a dedicated grounding path that is independent of the grounded circuit conductor. This can provide a higher level of safety and reliability, especially in situations where the grounded circuit conductor may be subject to high levels of current or voltage. In addition to the specific requirements of NEC 250.142b, there are other general grounding principles that must be followed when grounding meter enclosures. These principles include ensuring that all grounding connections are mechanically sound and electrically continuous, using appropriate grounding conductors and connectors, and following the manufacturer's instructions for grounding equipment. By following these grounding principles, you can help to ensure the safety and reliability of your electrical system. The NEC, or National Electrical Code, is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC is widely adopted by state and local jurisdictions in the United States and is considered the definitive source for electrical safety requirements. Compliance with the NEC is essential for ensuring the safety of people and property. Failure to comply with the code can result in fines, penalties, and even legal liability. It is therefore important for all electrical professionals to be familiar with the NEC and to follow its requirements carefully. In addition to the NEC, there may be other applicable codes and standards that must be followed. These may include state and local electrical codes, as well as industry standards such as those published by the Institute of Electrical and Electronics Engineers, or IEE. It is important to be aware of all applicable codes and standards and to follow their requirements when installing and maintaining electrical systems. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. If you have any questions or concerns about grounding meter enclosures or other electrical issues, it is important to consult with a qualified electrical professional. A qualified electrical professional can assess your specific situation and provide you with the best advice and guidance. They can also help you to ensure that your electrical system is compliant with all applicable codes and standards.